This is our introduction to exercise 9.7 on integrating y equals to 1 over x on page 420 of your textbook. We're focusing, of course, on integrating y equals 1 over x. It is a very particular type in the sense that it is, again, just another one of the formulas you have to add to your toolkit. So I would really recommend you write it in your resource book. And then, of course, you have to remember it, unfortunately, for exam 1 as well. So recall the derivative of ln, or natural logarithm, log base e, of x equals to 1 over x, which then therefore makes sense that 1 over x as derived is equal to natural logarithm of x plus c for where x is greater than 0. Now the reason why x must be greater than 0, of course, is because the domain of our function is x being greater than 0. You can't have a e to the power of something equaling to a negative number, so just keep that in mind. Referring to the chain rule, it works backwards and makes sense that we have the antiderivative of 1 over ax plus b equals to 1 over a, so the coefficient of the x, ignoring the b for now. So 1 over the coefficient of x multiplied by the natural logarithm of ax plus b, so that's our function on the inside or the bottom, and then plus c, of course, at the end. So it's a pretty straightforward formula after the fact. Let's apply this. So the first thing, looking at this question, and these are questions from Nelson, I must say. First part of this question is to identify how to make it into a more tangible form. Right now, 4x plus 6 over 2x minus 3, I don't have a formula for that. So instead, what I'm going to do is make my life a bit easier. Oh, sorry, before I continue, I just wanted to mention, you might see this, which is the antiderivative of 1 over x dx equals to the antiderivative of dx of x. Because the dx is not just part of the notation, it's actually part of the multiplication, they're just the same thing. Just keep that in mind. Okay, back to this question. 4x plus 6 over 2x minus 3. To make it a lot more easy, what I'm going to do is, first off, you could do polynomial division. Right? If you do polynomial division, you end up with a constant plus or minus something else, like a fraction on the side, which will look something like this. But you can also do it a little bit easier. So 4x, I'm just going to rewrite this, equals to, from 2 to 5, not rewrite that part because we're changing that part, but I know that 2x fits into 4x twice, right? So let's just double that one. 4x minus 6. Now, of course, it gives me 2 plus. Now, what I have to add in order to make them the same, right? So it end up being 2x plus 12 over 2x minus 3. Right? For example, if you were to multiply that by 2x minus 3, in order to make them the same denominator, and add them together, you get that. Or just do polynomial division, right? If you want to do polynomial division, I'll do it off to the side now. 4x plus 6 divided by 2x minus 3. Of course, 2x minus 3 goes with 4x twice, so that's 2x minus 6, right? So 2x, it should be 4x. And that becomes 12 remainder. So it's the same thing, I'm just giving it all to that. So you end up with this, of course, don't forget your dx, which then therefore becomes, because I'm anti-deriving, that becomes 2x from 2 to 5. And then plus, and I'm going to take this out first, okay? So it's going to end up being plus 12, and then I'm going to do my square brackets of 1 over 2x. Should be a square bracket, my apologies. Should be an integral of 1 over 2x minus 3 dx. Any questions about that? Okay. Well, we know how to do that. That's 10 minus 4, so that's going to be 6. Right? That's easy, we know that. Plus, now I'm going to do the antiderivative of this. So plus 12, I'm going to do my square brackets now and apply my formula from above. It's going to end up being 1 over 2. And then it's going to be ln of 2x minus 3, close square brackets with, I forgot to write 2 to 5. There we go, from 2 to 5. Solving that, and I am running out of space, so I'm going to write up here. Solving that, you end up with 6 plus 6 brackets, and I'm going to write them out here just to show you this step here. This would be what examiners would consider a reasonable simplification. You cannot leave it in this form. ln or log base e of 7 minus log base e of 1, of course, because it's subtraction, right? Think back to your log rules. You should end up with an answer of 6 plus 6 ln 7, because it'd be 7 divided by 1, so 7. Any questions? Okay. We're going to do a very similar example, the only difference being, of course, that it is a application question where you're looking for a function. In the second example, it says find f of x if f dash of x equals 2 over 6 minus 5x, and it passes through at 1, 0. So this same principles apply. F of x equals 2. I'm going to take the 2 out, so 2, and then I'm going to do my integral. You don't have to write the step out. This is just to make it really clear, but in your examination, you can go straight to the second step. 1 over negative 5 ln of, and I'm just going to rewrite that as negative 5 plus 6. That's a personal thing, it really does not matter. Got my plus c's. I need my plus c's, not definitely integral, so I need my plus c's. Especially because then I'm going to be solving for that c later on. So that's what we get, plus c. And we said, it says here, f of x passes through 1, 0, which makes sense for me to say that when I substitute points, 0.10s end up solving for c. So I'm going to put 0 here, and I'm going to replace the x with a 1. Which gives us an answer of 0 equals to negative 2 over 5 ln of 1 plus c. Thinking back to our log laws, e to the power of what gives us 1? Of course, it's a 0. So therefore, that's all 0. C equals to 0. Don't forget to put it back into your original equation. So therefore, f of x equals to negative 2 over 5 ln of, rewrite that, ln of negative 5x plus 6, no c involved. How do you feel about that one? Any questions? Okay. I'm going to go through 2 more examples, and then we'll call it there. So 2 examples. We've got, for example, we have from 2 to k, 2 over 2x plus 5 dx equals 7. We need to find k. Now this question is really, again, the same process with a slightly different step. You do your normal integration. So 2 brackets, that's not a bracket, integral from 2 to k of 1 over 2x plus 5 dx, which of course equals to 7. Which means that when I do my integration and apply the same rule, 1 over 2 log base n of 2x plus 5 from 2 to k equals to 7 over 2. Now I'm not going to go through every step, but you end up with ln of 2k plus 5 over 9, there we go, equals to, so we get to that stage. Just to be clear, because when you substitute your k, subtract your 2, I just factorize the 2 out and then times both 2 on both sides, which is why it's not 7 over 2 anymore. But you can't leave your answer like that. You need to find k. So you're applying your log rules. You would go to e to the power of 7 equals to 2k plus 5 over 9, which, solving that, you end up with an answer of k equals to 9 e to the power 7 minus 5 over 2. If I'm skipping over a step, by the way, and you don't really understand the process behind the step, I am expecting you to know it, so please make sure you go and revise that in your own time. Last example, this is a recognition question. It's more of a reminder, refresher for recognition. The question really is f of x equals to x of x multiplied, by natural logarithm of x. find f dash of x, and then the antiderivative of ln x. So first off, finding the derivative of f of x. Now, in most cases, when you're doing integration by recognition, the question will tell you what to derive first. If not, and you need to find your own differentiation first, you have to think to yourself, what do I derive so that my result, some component of my result, my differentiated result, is this. Right? If you keep that process in mind, essentially, if I derive this, right? Oh, sorry. When I derive this, this should be a part of it. If not, it's useless. Or I've done something wrong. Okay? Now, I'm sure you can do that differentiation process yourself. It's just your product rule. So f dash of x just equals to natural logarithm of x plus 1 plus natural logarithm of x plus 1. And again, you'll note that is a part of this. So, I'm saying that the antiderivative of this ln x plus 1 dx equals to, well, what's the antiderivative of my derivative? X ln x. Now, I'm going to split it up. Split it up, I get the antiderivative of my natural logarithm, dx, plus the natural logarithm of 1 dx equals to x ln x. I've done nothing fancy here. All I've done is I've just separated them out because now I can subtract this component on both sides. And therefore, I get natural logarithm of x dx, antiderived, will equal to x ln x, subtracting antiderivative of 1 dx, of course, minus x, and don't forget your plus c. Yes?
Just a question about notation. You know how you're talking about integration of 1 times dx?
Yep.
Would it be valid if you just do integration of dx?
No. I'm going to say no. Oh, no, that's correct. That'd be fine. Try to avoid that, but that would be correct. My apologies. Any other questions? Okay.